Hey everyone, and welcome. Today, we are going to do a complete deep dive into Amazon RDS. Seriously, if you're studying for an AWS certification or you're prepping for a tough technical interview, this is going to be your ultimate study guide. We're covering it all. Let's get right into it. So, here's our game plan. We've split this into 6 main parts. First, we'll cover the absolute basics. What even is RDS? Then we'll get into the nitty-gritty of its architecture and storage. After that, we'll tackle availability and security, super important stuff. Then we'll check out the more advanced versions like Aurora. And to wrap it all up, we'll talk cost and how to just crush those interview questions. All right, let's kick things off with Section 1. What exactly is Amazon RDS? To really get it, we have to start from square one and see why it's become such a fundamental piece of the AWS cloud. At its heart, Amazon RDS is designed to take away all the headaches of running a relational database. Think about all that boring, repetitive work, like provisioning servers, patching the operating system, managing backups. AWS calls this the undifferentiated heavy lifting. RDS handles all of it for you, and that lets you focus on what actually matters, right? Your application, its code, and your data. So this brings up a classic interview question. Why would you use RDS instead of just installing a database yourself on an EC2 server? Well, it really boils down to a simple trade-off. With RDS, you give up that low-level operating system access. But in return, you get this massive automation for things like patching, backups, and high-availability failover. So you're basically paying a little more per hour to save a ton of time and effort on operations. Okay, moving on to Section 2. We're going to dig into the core architecture. These are the real building blocks of your database, especially things like storage, that are going to dictate its performance and what it can do. The easiest way to think about an RDS instance is with a few simple analogies. The DB instance, that's your server, the compute power. The storage, well, that's the hard drive. The endpoint is the unique address your application uses to connect. The security group is like a bouncer at a club. It decides who gets in and who doesn't. And finally, the parameter group is like the master config file that fine-tunes how the database engine runs. Now, when it comes to storage, you've got a few choices, but here is the key takeaway. Seriously, just remember this. For 99% of workloads, you should just start with GP3. The reason is simple. It's really cost-effective, but more importantly, it lets you scale up your performance, your IOPS and throughput, without having to also add more storage space you don't need. You really only look at IO1 or IO2 when you have some extreme performance requirements. And that brings us to a super critical warning you absolutely have to remember. You can always increase the storage on a running RDS instance, no problem, but you can never, ever decrease it. So if you accidentally provision way too much space and you need to scale down, your only option is to take a snapshot, restore that snapshot to a brand new, smaller instance, and then repoint your application. It's a whole process. Let's get into Section 3, and we're going to tackle one of the most critical and honestly, one of the most misunderstood topics out there, availability and scaling. This is all about how we keep our database online all the time and make sure it's fast no matter how much traffic we get. Okay, if you remember one thing from this section, make it this. This is the most important distinction to get right. Multi-AZ is for high availability. It creates a standby copy of your database for automatic failover in case something goes wrong. But, and this is key, that standby copy is not readable. Read replicas, on the other hand, are for performance. They create readable copies of your database so you can spread out your read queries and scale your read traffic. In production, you're almost always using both together. And when a failure happens, how fast does multi-AZ actually recover? Well, typically, it takes between 60 to 120 seconds. This is what we call your recovery time objective, or RTO. So in about 2 minutes or less, AWS will automatically fail over to that standby, and your application is back online. So how does that magic actually work? It's really just a 4-step dance. First, RDS detects that something's wrong. Second, it promotes that standby instance to be the new primary database. Third, and this is the most clever part, it automatically updates the DNS record to point to the new primary. This means your application, which just connects to that DNS name, doesn't need any changes. It just reconnects and keeps going. All right, in Section 4, we're shifting gears to security and operations. This is all about the best practices for locking down your data and just keeping your database healthy and running smoothly day to day. Security in RDS is all about having layers, what we call defense in depth. You always start at the network level, putting your database in private subnets and using strict security groups. Then you encrypt the data on the disk. That's encryption at rest, using KMS. You encrypt the traffic moving over the network with SSL. And finally, you manage who can log in using IAM authentication, and you store your database passwords safely in Secrets Manager. Okay, here is another one of those massive exam points you have to know. Just like with storage, you cannot just flip a switch and turn on encryption for a database that's already running. You have to decide on encryption when you first create it. If you have an unencrypted database and need to encrypt it, the only way is to take a snapshot, make an encrypted copy of that snapshot, and then restore from that encrypted copy to a whole new instance. So what about big, scary operations, like a major database version upgrade? How do you do that without taking your application down for hours? The modern way to do this is with blue/green deployments. AWS basically clones your production database, creating a perfectly synchronized staging environment, which we call green. You can test everything there safely, and when you're ready to go live, you just switch over. And that switch takes about a minute, with virtually zero downtime. It's a game changer. So far, we've pretty much just talked about standard RDS. But in this next section, we're going to dive into some of the more specialized, more advanced versions. We'll look at things like Aurora, RDS Custom, and RDS Proxy, and figure out when and why you'd want to use them. And this is where you can really see why everyone calls Aurora the cloud-native database. The absolute biggest difference is the storage layer. See, with standard RDS, each database has its own disk, but with Aurora, they all use a single shared storage volume. And that one architectural change makes all the difference. Replication is almost instant. We're talking millisecond level lag, and it cuts that failover time down to under 30 seconds. It's a beast. And what about RDS Proxy? What's that for? Well, here's the #1 use case to remember: serverless applications, especially AWS Lambda. When a Lambda function suddenly scales up to thousands of concurrent executions, all of them try to open a database connection at once, and that can completely crush your database. RDS Proxy sits in the middle and acts as a connection pooler. It takes in all those thousands of connections and funnels them down into a small, manageable number that your database can actually handle. Okay, let's bring this all home with our final section. We're going to get super practical here, talking about how to save money and how to absolutely nail those tricky RDS interview questions. This is where all the theory we've learned meets the real world. So what's the single best way to save money on RDS if you have a predictable long-term workload? Easy, reserved instances. By committing to using a specific instance for a 1 or 3-year term, you get a massive discount on that hourly compute cost. I mean, you can save up to 69% if you're willing to pay for a 3-year term all up front. All right, let's practice for that interview. Picture this. The interviewer leans forward and says, "Your application is running slow, and you suspect it's the RDS database. Walk me through how you diagnose the problem." Let's break down the perfect 4-step answer. Here is your expert 4-step answer. Step 1. I'd start with Performance Insights. That's the best tool to find the exact SQL queries that are causing the most load on the database. Step 2. Then I drill down into the wait events for those queries to see what the database is actually spending its time waiting on. Step 3. I take the problem query and run an explain analyze on it. That shows me the query plan, and it'll usually reveal if I'm missing an index. And finally, step 4. If the whole database seems slow, not just one query, I'd check the high-level CloudWatch metrics for a system-wide bottleneck, like CPU, memory, or IOPS, and scale the instance up if needed. Wow, we have covered a ton of ground today, from the absolute fundamentals all the way to advanced architecture and even interview prep. So to bring it all together and get you thinking, I want to leave you with one final question to consider for your own applications. Based on everything we just discussed, what is the one RDS feature you could go and implement right now that would have the biggest impact on your application's resilience? Think about it. Thanks so much for joining me.